Good morning, physics class. Last video for our centripetal, circular motion, talking about centripetal acceleration as well as centripetal force or tension force. We did tension force in the last video. We're not going to be talking about tension for strings, that kind of stuff. We'll be talking more about centripetal force, which is the force, again, acting on something when it's going in a circle. That force is going to want to push the vehicle, the vehicle is going to want to stay, continuously being, let's go through a question. I'll draw it out. It'll make more sense when we have that video in the background. All right, we're going to focus on question 8 from the practice sheet as well as question 1 from practice sheet number 2. They both deal with vehicles going around corners. One talking about friction, one talking about a banked corner. They're both going to kind of bring some dynamics work into this. And so that's what we're going to focus on in this video. All right, here is question 8 from the practice sheet. So it says, a car rounds a curve of a radius of 50 meters. So radius equals 50 meters. Okay, at a speed of 80 kilometers an hour. Let's, again, change this to meters per second instantly. I think it's 22.2 is what I calculated. Just divide by 3.6 if you haven't got that by now. Okay, kilometers per hour to meters per second, divide by 3.6. We get 22.2. Okay, so velocity or speed equals 22.2 meters per second. And there's a mass of 1200. Okay. So basically, this car, we'll just draw a curve. Okay? A car is not going over the hill, but think of this as this is the actual road it's traveling. So this is a top view, okay? Top view of it going this way, okay? When the car is traveling this way, again, it's going to want to stay in an actual straight linear motion. So the car wants to keep going this way. To consistently actually turn, there has to be a force always inwards, okay? There always has to be a force going inwards towards the middle. This is the force, okay, that we need to be coming in, okay? If it's by string, it's by tension, but basically, again, otherwise, if there's not that much force, it's going to slide out. It's going to go out, okay? So we talk about this force pushing out. There has to be a force pushing it in to keep it there, otherwise it's just going to slide out. So let's first off figure out, it says how much, what is the centripetal acceleration? So this one's not hard, this one's pretty easy. Acceleration equals v squared over r, so 22.2 squared, 22.2 squared, that's a lot of 2's, over 50, and I get an acceleration of, what do I have for an answer here? Acceleration of 9.9 meters per second squared. Okay, B is also an easier one to answer. C is the harder one, so B, well not harder, but it takes a little more work. B, how much centripetal force is needed? Well, now that I have acceleration, force just equals mass times acceleration. So 1200 times 9.9 equals 11,880, if I'm looking at my work correctly, newtons. So that's how much force is needed this way, like the red one, that's how much force is needed this way to keep it on this curve. If not, it is going to start slipping and sliding outwards and staying on a more linear path. You can only turn so much if you're going so fast because you need a certain amount of friction. Okay, now I kind of just gave away. What does this force come from? It comes from either the friction between the tires and the roads, like when you turn, the friction will keep it there, or if there's an angle to the actual, like if you've ever gone over an overpass, it's usually angled, that way you can go faster because that angle is going to want to keep you going this way, okay? If you're on an angle like this, okay, if your vehicle is on this, you need an angle inwards, which this will then be kind of force parallel. Force parallel will help with this force circular, okay? In this instance, we have no angle, but we do have friction, okay? It says C, if the coefficient of friction is 0.25 on a slippery road, will the force of friction between the road and the wheels of the car be enough to keep it from skidding? So basically, friction has to do 11,880 newtons of force to make sure that this stays in perfect circular motion. Otherwise, it's going to slide outwards into a more linear pattern. All right, so let's figure out what our force of friction is. Force friction equals force normal times mu. We have mu, 0.25. Force normal in this sense will just be force of gravity. There's no angle whatsoever. So in that sense, nicely, we don't have to worry about finding a force parallel or a force normal with an angle. It's just on a flat road, so same as force gravity. So force gravity is going to be just 1200 times 9.8. So 1200 times 9.8 gives me 11,760, and when I multiply this together, I get a force of friction that is not even close to what we have the other one. Force of friction of 2,940 newtons. So not even close. Okay, we needed that much force. All we got is this much force from friction, 2,940, so it's not even close. This car is very much going to slip and slide outwardly and like stray closer to a linear path. It's not going to be able to follow this circular motion because again, there's just not enough friction force to keep this this actual force, the circular force, inward. It's going to slide outwards and not follow that path. Okay. So there's question 8. Question 9 is similar when we're talking about, again, this outward force and keeping this, this force to stay on a circular path. This is now question 1 from practice sheet number 2. This one here. Okay, so it says a car is traveling around a circular track, a radius of 100 meters. So radius, 100 meters. Okay, at a constant speed of 20 meters per second. Okay, mass 1200. Okay, what is the acceleration of the car? Okay, so acceleration, again, v squared over r, 20 squared over 100, and I get a 4 meters per second squared. So that's my acceleration, 4 meters per second. What force is keeping the car in the circular motion? So let's just find the force. The force equals mass times acceleration. So 1200 times 4 gives me 4,800 newtons. What force is actually keeping that? Like again, if I have a circular track, what force is actually keeping that in? It's either one of two forces. Again, it has to be either friction or with the help of force parallel. And in this instance, there is a banked curve. It's as if the track were to be banked at 21 degrees. So I now have 21 degrees here, 21 degrees. Would the car be able to navigate the curve with only force parallel? So for some reason there's no friction anymore. But if we just were to have a perfect bank and have force parallel, would it be enough force to have 4,800? Well, let's figure out force parallel. Okay, force parallel, if we go back to our nice formula, is just force of gravity times sine theta. Okay, that kind of looks more like force y, force gravity. So, which means I'm going to be going mass 1200 times 9.8 times sine of 21. And when I do that, when I put that all together, I get 4,000. Oh, that works in the back. 200 and something? 4,214 newtons. So, it's close, it's close. Force parallel can do most of the work pushing inwards towards the middle, but not all. Okay, so the answer here would still be no. It's not going to be able to do all of the work. It would be close. You'd have to do some frictional force as well, which obviously there would be between the tires and stuff, but force parallel cannot do all of the work here. Okay, but just talking like when vehicles or bikes or things are going around corners, what's keeping it in that actual, like what's keeping it in that circular motion? Again, it either has to be a force parallel, and the nice thing is, if you're riding your bike and you imagine like leaning to the side, that's kind of also making that force parallel turn. Like it's just like a banked corner or like a banked curve. You're creating more inward force to get that force parallel. Same with cars, when you have a banked corner, that force parallel can help that inward force. Okay, last video, thanks so much. You'll be getting an assignment right away. If you have any questions at all about any of this, just let me know. Thanks so much, class. I'll talk to you later.